We first learned how to factor and solve quadratic functions. Now we're going to learn how to graph quadratic functions. So remember, a quadratic function, we've seen them in two forms so far. We've seen them in standard form, where we have ax squared plus bx plus c. And you probably remember that most from the quadratic formula, although anytime we factored a quadratic function, it started in standard form. Our a value was usually 1. And we've seen them in factored form. Y equals x minus c times x minus d. Now those could also be positive. There's a third form of a quadratic function, and that is vertex form, which is what we're going to learn how to graph first. So taking a look at vertex form, our a value on the outside tells us if the graph opens up or down, and whether we have a fat graph or a skinny graph. The h is the x-coordinate of the vertex. And for those of you that had me try too, when we talked about point-slope form, you may remember my asylum analogy. For those that did not have me try to or forgot about the analogy, anything that is in the parentheses grouped with the x is not normal. It's in the asylum, so it doesn't act the way we think it should act. So inside the asylum, it looks like a negative h, but outside in the coordinate for the vertex, it's positive. And then we have our k value that's outside the asylum, and it looks positive, and when you put it in the coordinate with the vertex, it is positive. Before we learn how to graph, there is a special name for the graph of a quadratic function, and it is called a parabola. A parabola either looks like a U or an N. So that a value, as I mentioned, tells us if the graph opens up or down, and the vertex would be the turning point of the parabola. So for a parabola that opens up, it would be down here, kind of the bottom of the graph. And for a parabola that opens down, it would be at the top of the graph. That's called the vertex. So that's what we learned how to identify from our vertex form a minute ago. And finally, we have what's called the axis of symmetry. That is an imaginary line through the graph. Sometimes I'll draw it for you as a dotted line that goes through the vertex, and it's a line across which the graph could be reflected. It creates a mirror image in the parabola. The equation for the axis of symmetry is x equals h, where h is the x-coordinate of the vertex. And remember, vertical lines have an x equals equation. So starting off, to get us used to all of the vocab, we're going to start with the most basic form of a parabola, or the most basic form of the graph of a quadratic function, and that's simply y equals x squared. So we're going to start by setting up our t-chart, x values and y values, and then we can choose any x values we want to. It's helpful to choose both positive and negative x values, and then we're going to substitute those into the function. So remember, when we take a -2 and square it, multiplying something by itself creates a positive. So we get a positive 4. -1 squared becomes a positive 1. 0 squared, of course, is 0. 1 squared is 1. And 2 squared is 4. So we're going to plot those ordered pairs on our graph. -2, 4. -1, 1. 0, 0. 1, 1. And 2, 4. And then we'll create a smooth curve. It does not have a sharp turn. It, like I said, looks like a U or an N, so it curves at the bottom or the top. So let's talk about all of that vocab. First of all, for this, our vertex, our turning point is 0, 0. And then the axis of symmetry is a vertical line that the graph is reflected across, and it's x equals the x-coordinate of the vertex, so in our case, x equals 0. So if we were to sketch the axis of symmetry, it would be, in this case, the y-axis. It's a vertical line that goes right through the center of the graph. Now we're going to learn how to graph in vertex form. It's a little bit more complicated form of the quadratic function. So our first goal is to identify the vertex. Remember, the x-coordinate is grouped with the x inside the parentheses, so we'll have an x-coordinate of +2 because it's in the asylum, so it's not normal, it's the opposite of what we think. And then we find the y-coordinate, which is outside the asylum, and it's normal. Once you find the vertex to set up your t-chart, you want to put the vertex in the middle and then choose two values smaller, two x values smaller than the vertex, and two x values bigger than the vertex, because that's the turning point of the parabola, so you want to see what's happening on both sides of the vertex. Then you can substitute those values into the function and solve for y. Order of operations, we do what's inside the grouping symbols first. 0 minus 2 is negative 2. Next step in order of operations, we've got that power. So negative 2 squared is 4. We'll multiply before we add. 8 plus 4 is 12. What's nice about the parabola is that because it's symmetric, on the other side, we'll get 412 as well. So thinking about if we substituted a 4 in instead of the 0, everything would come out the same, except for we would have had a positive 2 inside the parentheses. So now we'll substitute 3, because I'm out of room to substitute the 1. So we have 2 times 3 minus 2 squared plus 4. 3 minus 2 is 1. 1 squared is 1. 2 times 1 is 2. And 2 plus 4 is 6. So we'll get the same thing as if we substituted 1 in, because once again, we would get the same value, but it would be negative 1. Once we square it, it becomes positive, and the rest is the same. So now we'll plot those coordinates. 0, 12 doesn't quite fit on the graph, so I'm just going to put it above the graph. 1, 6. My vertex at 2, 4. 3, 6, and 4, 12. The skinnier the graph, the harder it is to make a nice curve. It looks like it should be a sharp turn. Every parabola has a smooth curve, never a sharp turn. So make sure you've got that smooth curve. I'll be looking for that on all of your graphs. We already identified our vertex, so next we need our axis of symmetry. Remember, it's x equals the x coordinate of the vertex, so in this case x equals 2. And if we were to sketch that in our graph, go right through the vertex, that vertical line at x equals 2. Our final graph, identifying the vertex, we take that x coordinate out of the parentheses, and it becomes opposite. So this time we have negative 2 for the x coordinate of our vertex. The negative 1 on the outside stays normal, so it stays a negative 1. Creating our t-chart around the vertex, putting that negative 2, negative 1 in the center, 2 x values smaller, and 2 x values larger than the x coordinate of the vertex. 0 is an easy number typically to work with, so I'm going to start by substituting that, replacing our x with 0. Again, order of operations, grouping symbols first, so we have 0 plus 2. Exponents, 2 squared is 4. Multiplication, negative 3 times 4 is negative 12. And then subtraction, negative 12 minus 1 is negative 13. And because if we put the negative 4 in, we would get the same thing because our graph is symmetric. We get 2 answers. Again, due to room for work, I'm going to substitute negative 3 this time. We get negative 3 times substituting the negative 3 for x. Order of operations, inside the parentheses, we get negative 1. Squaring our negative 1, we get a positive 1. Multiplying our negative 3 by 1. And then finally subtracting 1, we get negative 4. Graphing those values, starting with negative 4, negative 13. Again, that one would be off the graph. Negative 3, negative 4. Our vertex at negative 2, negative 1. Negative 1, negative 4. And 0, negative 13. So this one's really skinny. But again, when you graph this one, do your absolute best to make that rounded curve at the vertex. Our axis of symmetry would be x equals -2, the x-coordinate of the vertex. So if we were to put that on the graph, we would have this vertical line through x equals -2 that we could flip the graph across. And finally, we had two graphs that open up and one graph that opened down. So let's take a look at the difference between those equations to see if we can figure out how to tell if the graph opens up or down. This a value on the outside was negative for example 3, and our graph opened down. On example 2, our a value was positive, as well as example 1, what we were multiplying our x squared by was +1 in this case. So if a is positive, your graph will look like a U, or opening up. If your a value is negative, your graph will look like an N, or it will open down. And finally, I have a U try for you. Identify the vertex, the axis of symmetry, and get a sketch of the graph, making sure that it's consistent with your equation. Just like when we were graphing lines, if the slope is positive, your line should rise. If the slope is negative, your line should fall. Make sure your equation is consistent with whether or not your graph opens up or down.